The night the numbers screamed, we open mid-crisis. A junior analyst watches the Atlas dashboard erupt with an object whose trajectory slices across the solar system like it missed the memo on orbits. Alarms blossom, coffee goes cold, and a single outlier point refuses to behave. A chill line.
That's not from here.
The room is the color of screensaver blue and sleepless fluorescent. The air hums with fans and quiet dread.
On the monitor, a tidy cloud of familiar points, little dutiful citizens of the sky, doing their elliptical commutes, suddenly has a rebel. It is not loud. It simply refuses to curve. That straightness is the first act of disobedience, the kind that makes scientists sit up like someone just knocked over a law of nature and left without leaving a note. The analyst drags a rectangle across the plot, zooms, and the anomaly survives the magnification like a line etched by intention. The timestamps tell a story in heartbeats: detection, confirmation, follow-up. The software offers a first pass on motion. It estimates a speed that makes neighborhood asteroids look like pedestrians at a crosswalk. Crucially, the residuals, the little numerical confessions of how wrong your model is, do not shrink when you force an orbit around the sun. They bulge, they sulk, they say, please stop pretending. A key insight hits in the second minute. Bound objects yield to gravity's choreography. This one is crashing the party from beyond the velvet rope. Could be a satellite, someone whispers, but the brightness curve says otherwise. No glinting panels, no repeating flare that screams metal. The image differencing algorithm has already subtracted known catalog stars and tracked the streak across frames, a hopscotch in pixels that spells out one word with each jump: inbound. The analyst calls out coordinates, voice steady in that way people get when everything is not. A second observatory answers with a copy of the same weirdness. It is like asking a friend if they hear the same thump in the basement and they text back, yes, also it brought luggage. Another monitor shows the raw frames, long streaks like someone scratched the sky with a silver needle. The telescope's auto-guiding continues, stubborn as a metronome, while the object writes its own tempo across the sensor. Astrometry software spits out a preliminary track, then a trajectory fit. The number next to the word eccentricity is not just large, it is unashamed. The line on the simulation screen refuses to bend into a family curve. It is hyperbolic in the way drama students wish they were. If orbits are cozy circles and elongated ovals, this is a goodbye letter that starts with hello. In the control room, humor is how fear wears a cardigan. Someone quips, Earth is basically a rock that won the cosmic lottery. Please tell me the prize is not a surprise guest. Nervous laughter does its job. The analyst swallows, fingers hovering over a keyboard shortcut that sends a quiet ping to a list of watchful inboxes around the world. Eyes ricochet between panels, brightness over time, position over time, a synthetic view of the path relative to the ecliptic plane. The path ignores it like a tourist ignoring crosswalks in a city they will never visit again. The lead on duty walks in, still half-zipped into a jacket that advertises a conference in a year no one wants to relive. One glance, and the jacket is already being shrugged off. The lead does not ask for backstory. There is no time to narrate the past when the future is already sprinting. Get me residuals on a non-bound fit, they say. The analyst does. The software sighs with relief. Suddenly, the numbers behave. That is the paradox. When you admit the object is free, the math calms down. Give it the status of a visitor, and the equations shake hands. A plot of brightness variation starts to grow teeth. It is not flat. It rises and dips with a rhythm that suggests spin, maybe a tumble, maybe something stranger. In the second hour, the light curve already hints at an object that is not a neat ball, but something with personality, edges, facets, an awkward silhouette that catches sunlight, like a nervous actor finding their light. There is a smack of humility in the room. Nature is not obligated to be spherical for your convenience. A dance. The chat channel fills with pointings and timestamps, a small militia of telescopes pivoting in the night. There is no siren, just the quiet escalation of competence. Observers request exposure times, photometrists volunteer calibrations, dynamicists promise a first pass at a trajectory that pretends nothing is impossible. The analyst watches the map of the inner system bloom with icons. Each one is a borrowed eye. Each one is a vote that this matters. The running hypothesis gets a nickname in the chat because humans cannot help themselves. Someone writes 3I candidate as a shorthand, a way to mark the possibility that this is not just an unusual rock, but the third time the galaxy has mailed us unrequested material. No one says the word interstellar out loud at first, like it might scare the thing away. Still, the work pushes on. The analyst locks the pipeline to prioritize the object, a subtle triage that says we will miss a few ordinary meteors tonight and sleep okay about it. The lead leans over the analyst's shoulder as the first crude projection lands, an animation of the object's future arc. It will graze the sun's influence, then slingshot out. The grace of it burns a little. It is the kind of path you get to study once, if you are lucky, twice if the universe is feeling generous, and a third time only if it wants to keep you humble. The humor returns in a whisper. It missed the memo on orbits, the analyst says, and this time the room laughs for real. That line will end up in a newspaper later, misattributed to a person who was not there. That is fine. Tonight is not about credit. It is about getting the numbers right before dawn. A final check. Is this a glitch? A reflection? A ghost in the detector? The team throws the kitchen sink of skepticism at it. Cross-checks agree. The object is real, fast, and not a member of the local club. The analyst lets out a breath they did not notice they were holding. Outside, the night looks exactly the same to everyone else. On the inside of this room, the universe has just pulled up a new tab. By sunrise, the emails will be flying, the forums buzzing, and the longer story will begin. Who built this watchful system? How the algorithms taught themselves to smell trouble, and why our planet now keeps a cosmic guestbook. That is the next chapter. For now, the opening scene holds an outlier point that refused to curve, a room that refused to blink, and a quiet certainty settling in. This is not from here. In Chapter 2, we rewind just enough to ask the obvious. Who wired the sky with tripwires? And how did we learn to hear when the night screams softly? Chapter 2, who turned the sky into a tripwire? Who turned the sky into a tripwire? Not a single hero with a telescope and a cape, but a patient machine built by people who decided that if rocks can sprint, we should at least hear their footsteps. The asteroid terrestrial impact last alert system, politely called ATLAS, is the cosmic equivalent of a neighborhood watch sign posted on the entire planet. It is not glamorous. It is a pair of wide-eyed telescopes planted on volcanic rock, blinking through the night like they are trying to memorize the sky by heart. Each eye takes in a huge swath of stars, snaps, and snaps again, then asks a simple question with very dramatic consequences. What moved? The trick is not just taking pictures. Anyone can take a photo of the sky and feel noble about it. The trick is cadence, that heartbeat of repeated exposures at just the right spacing so that a fast mover betrays itself. Atlas sweeps, pauses, and sweeps again, building a rhythm that makes slow cosmic citizens blur into background routine, while anything racing through the foreground pops up like a dancer, stepping out of line. Imagine the world's most obsessive difference game. Spot the change, except the prize is time. Hours to days of it. Time to warn, time to measure, time to not be surprised by physics. Under the hood, algorithms do what tired humans cannot. Raw frames are messy. Wind nudges, optics sigh, atmospheric shimmer, scribbles across starlight, and clouds audition for the role of villain. The pipeline cleans all that with the ruthlessness of a forensic lab. Known stars are matched to a catalogue and subtracted, hot pixels are excused from duty, and faint streaks get amplified just enough to be interrogated without inventing ghosts. The software is part detective, part bouncer. It checks a candidate against a long memory of satellites, catalogued asteroids, and every usual suspect that tends to crash the party. It asks, are you something we have already met? If yes, back to the line. If no, the velvet rope lifts. There is a classifier trained on the bad habits of the night. Airplanes leave stubborn trails. Insects perform modern dance across the sensor. And the occasional raindrop tries to cosplay as a threat. The classifier has seen these tricks. It throws out the fakes with a dispassionate flick and hands the stubborn remainder to humans who still trust their eyes more than any score. Best handoff is the secret spice. A scientist can look at a 4-frame sequence and feel the intention in a streak. The way a line keeps pace with the clock. The way an imposter fails to breathe over time. The machine sifts. The human judges teamwork, but with starlight. Hardware matters too. And Atlas keeps it simple and fast. Big mirrors win prizes at conferences, but wide fields win at watch duty. The mounts swivel like dancers with perfect balance, hopping from patch to patch with a choreography that maximizes coverage while leaving enough revisits to catch something that is not interested in lingering. The shutters clack, the cameras chill, and the dome listens to weather like sailors listen to the sea. If the humidity spikes or the wind threatens to shove, the system knows when to duck and when to muscle through. Planetary defense may be noble, but it is also very practical. Keep the gear alive, keep the cadence steady, keep the data clean. Then there is the people part. The reason the whole thing feels less like a machine and more like a promise. Night assistants cradle hot mugs and colder keyboards, carrying institutional memory in their heads. Which filter is fussy? Which cable gets shy? Which menu hides the only button that matters at 3 in the morning? Pipeline wranglers speak fluent error message. Observers at partner facilities keep an ear out, ready to pivot at a ping from halfway across the world, because the sky does not care about your time zone. There is even a quiet choreography of calibration, standard fields, check exposures, twilight flats, that keeps the numbers honest. You do not see it in the headlines, but it is the difference between a scare and a finding. Atlas does not hoard what it sees. When a candidate clears its gauntlet, an alert message trots off to a global clearinghouse, where astronomers trade positions like breaking news. Within minutes, other instruments swing to look, some with bigger mirrors, some with different colors, some with tricks that reveal motion you cannot see in a single snapshot. The point of the tripwire is not applause, it is a relay. One team trips, many teams sprint. If the object is small and nearby, the payoff is warning time, hours to move an aircraft route, days to choose which headlines to write, maybe weeks to test the emergency playbook. Everyone hopes to keep laminated and unwrinkled forever. Why call it a tripwire rather than a net? Because the sky is too big for nets and too stubborn for fences. You lay thin lines of attention across it, spaced so that a fast step will always catch a toe. The humor in this is that we once treated the heavens like a calendar, and now we treat them like a motion sensor. Humanity upgraded from romance to vigilance without losing either. We can still gasp at a meteor shower and also ask, very calmly, how early we would like to know about the loud ones. The stakes are not abstract. A good night for Atlas is boring data and better sleep for the rest of us. A great night is catching something small enough to burn out, but big enough to startle, with time to say, look up, but do not worry. The hard nights are the ones where the dashboard hints at a stranger, shaped by a distant sun, moving with the confidence of a traveler who never needed our gravity in the first place. Those nights remind us why the system exists. The sky is ancient. Our senses are new. The only way to feel less small is to be more watchful. So, who turned the sky into a tripwire? A chorus of engineers, coders, observers, and managers who decided that bedtime should not include cosmic surprises. The system is persnickety, the schedule relentless, and the payoff mostly invisible. And that is exactly the point. In the next chapter, we follow the label that sometimes appears when a candidate behaves like a citizen of somewhere else entirely, and we explore what it means to be the third visitor from far beyond our star. Chapter 3, 3I. The name you earn by ignoring the sun's rules. 3I. The title sounds like a spy agency or a pop band, but in this story, it is a passport stamp that does not exist, awarded precisely because the traveler never queued at customs. Third interstellar visitor is not a poetic flourish. It is a verdict delivered after a checklist of rude facts. The object is moving too fast to stay. Its path through the solar neighborhood never closes into a loop, and even when you correct for every wobble of planets and the sun, it still carries a leftover dash that gravity cannot leash. The universe writes many itineraries. This is the one that says one way. How does that label get earned? Not by hunch and not by enthusiasm. First, a swarm of measurements pins down positions against a background of stars that do not budge in a single night. From those positions you build a path, and from that path you infer a story. If the story says the traveler merely looks hurried but will eventually curve back like a homesick boomerang, then it is local. If the story says the traveler is on a line that will never round off, you pay attention. The language astronomers whisper to each other translates to something very plain. This course is an open road. It will not loop. It will not be coaxed into a family reunion around the sun. Not now, and not on any schedule the planets can provide. But a label this big does not get slapped on after a single night. The adjudication has the drama of a courtroom and the patience of a glacier. New observations extend the arc, errors shrink. You fold in influences from the major planets, from the subtle tug of the sun's not quite perfect shape, and even from the soft pressure of sunlight itself. If the verdict still says runaway, you look for ways you might be fooling yourself. Was there a misidentified star? A clock that blinked? A camera that stretched a streak into false bravado? The prosecution and the defense live in the same heads. Only when the case survives the most boring questions does the excitement earn the right to speak. Then comes the naming ceremony, which is less champagne bottle and more filing cabinet. The discovery pipeline assigns a temporary code that looks like a robot trying to remember the alphabet. As other teams report their measurements, a central ledger gathers them, computes a refined path, and if the evidence holds, changes the object's very surname. The letter that matters is the I. It means interstellar. It turns an anonymous track into a member of a tiny, exclusive club whose meetings are brief and unmappable. The first two members already rewired expectations. A third does more than add a tick mark. It starts to look like a pattern, and patterns make scientists lean forward like they just heard their name across a crowded room. Why does ignoring the sun's rules matter so much? Because our star is a generous tyrant. It owns most things that wander near. A stray rock with modest speed will find itself captured into a stretched oval, and eventually either settle into a routine or meet a fiery appointment. To walk away from the sun, you need confidence. That confidence comes from birth elsewhere. The object was trained under another star's gravity, ejected by distant chaos, and has been coasting ever since. Imagine a snowball that formed in a far country, survived a string of summers without melting entirely, and then barreled down our street without slowing for school zones. The message is not hostile. It is simply blunt. There are other neighborhoods, and their leftovers sometimes cross ours. The I label also changes the questions we ask. If something is local, we interrogate its family history. Which asteroid belt? Which comet reservoir? Which ancient collision? If something is interstellar, we ask about other suns. What sort of planetary workshop throws parts this far? How violent must the early days of a system be to send debris onto a journey that spans light and loneliness. The traveler carries a chemistry kit and a sculpture lesson, a surface shaped by unfamiliar seasons, a blend of ices and dusts needed by a star that is not ours. Even its spin might whisper stories about past near misses or slow baking in a foreign dawn. There is also the matter of etiquette. Visitors do not stay for long. The clock for meaningful looks and thoughtful measurements is tight. Every hour lost to doubt is an hour the traveler uses to shrink into the deep, hence the urgency behind the label. Interstellar is not only a category, it is a command to prioritize. Point the larger mirrors, swap to the right filters, call in the spectroscopists who can persuade a faint smear of light to confess elements and textures. It is the astronomical version of upgrading a casual hello to a formal interview while the guest is still on the porch. And yes, there is the half-joking plea. Please tell me it does not have a return ticket. This is not fear of invasion. It is respect for sanity. Planetary defense folks prefer their surprises small and their trajectories dull. An object that roars in from a foreign highway is mostly a lesson, but lessons can get loud if the geometry is unkind. The good news is that space is tremendously roomy. The geometry is almost always polite. The bad news is that almost always is not a bedtime story. The label 3I reminds everyone that the solar system is not a closed room. The door is open both ways. Things go out, things come in. It pays to keep the porch light on. The third entry in this ledger also presses on a philosophical bruise. We like to imagine the solar system as a self-contained stage with predictable actors. 3 outside guests in the span of a scientific career say otherwise. They say the galaxy is not just a backdrop, it is traffic, and every so often, traffic glances our way. We are not the capital city. We are an exit on a very long road. There is comfort in that humility and also a spark of treasure hunt. Each visitor is a sample return mission. We did not have to launch a free courier service from elsewhere, even if the delivery van refuses to stop. By the time a candidate earns its eye, the community has shifted into coordination mode. Observatories hand off targets like relay batons. Modelers set up their digital arenas. Artists begin sketching shapes that might or might not be real, because imagination is the scaffolding you stand on while the data climb up. Perhaps most thrilling of all, archives wake up. Teams scour old images from before the announcement, hoping to find the traveler months or years earlier, a faint whisper in a corner of a forgotten frame. Every extra breadcrumb tightens the path, and with it the certainty that this really is a story from away, all of which sets the stage for the most unromantic, most vital part of the adventure, the dump. Not of trash, but of data, a tidal wave of numbers and images that turn mystery into evidence. In the next chapter, the fire hose opens, and we walk through what poured out, how to hold it without drowning, and why a single folder of raw sky can feel like a confession written by light. Chapter 4, Data Dump Day. The fire hose opens, the newest release lands with the grace of a piano dropped from a modest height. Folders bloom like nervous flowers, raw light curves, streaked images, calibration kits with names that sound like vitamins, and telemetry that reads like a sci-fi lie detector wired to the entire observatory. No hero shots here, just files. Each one a brick that does not look like a cathedral until you place it next to 10,000 others. Start with the streaked images, the glamour shots for people who think glamour is a straight line at a suspicious angle. These are the primary frames in a format that astronomers trust more than their own handwriting. Files with headers longer than a short novel, listing when, where, how, and under what mood the sky was photographed. The header is a confession booth for hardware. It admits the exposure time, the filter on duty, the air mass the light slogged through, the temperature of a camera that prefers winter in all seasons, and the precise clock tick that marks each photon's arrival. The pixels themselves look simple until you zoom and realize they are tiny stagehands, each reporting how much starlight fell into its square patch of night. When a fast mover scrawls across the sensor, the point spread function stretches into a trail. Measuring that trail, its length, thickness, angle, turns a bright scratch into speed, direction, and intent. Think of it as handwriting analysis for objects that refuse to stay still long enough to pose. Raw light curves live in humbler spreadsheets, but they are where the heartbeat hides. Each row represents a timestamp and a brightness measurement, corrected for instrumental quirks, and scaled to a standardized brightness system so that a value means the same thing at midnight and at dawn. The clever part is the selection of aperture sizes, like choosing the right spoon to taste a soup that keeps trying to slosh out of the bowl. Too small and you miss light, too big and you sip background sky. The pipeline offers both and lets the analyst judge which spoon fits the mess. Quality flags ride along, little yes-no sticky notes that warn you when a measurement might have been photobombed by a cosmic ray or nudged by a gust of wind. A good light curve is not just a sequence of numbers, it is numbers with the courage to admit when they might be lying. Calibration files do the unglamorous core of teaching the other files how to behave. Bias frames are 0-second peaks at the camera's own nervous system, electronic offsets that need subtracting so that darkness does not masquerade as faint starlight. Dark frames reveal thermal mischief that grows with exposure time, a warm whisper that has to be removed or you will think the universe is brighter than it is. Flats are the housekeeping staff, measuring dust motes, pixel-to-pixel appetite differences, and vignetting, so the final images are not haunted by the camera's personality. Together, these are the vegetables on the plate. Eat them, and the main course becomes nutritious instead of merely tasty. Skip them, and you are doing astrology with better graphics. Telemetry is the diary the telescope did not know we would read aloud. Focus positions drift as steel and glass yawn under the night's temperature slide. Seeing the atmospheric blurriness score rises and falls like the mood of an ocean. The guiding system reports how well it kept the stars pinned, while the Earth rotated with all the subtlety of a lazy carousel. Wind speed, dome orientation, humidity spikes, even micro vibrations from a motor that prefers decaf, all recorded. Later, when a light curve shows a suspicious dip, the first question is not what physics is this, but what did the weather say? If the telemetry stamps sympathy at the same moment, you mark the dip as drama, not discovery. This is how grown-ups keep magic from sneaking in through the service entrance. The conversion from cosmic static to sentences begins with alignment. Star catalogs provide a map. The image is the landscape painting you rotate and stretch until landmarks match. When the astrometric solution locks, pixel coordinates turn into right ascension and declination, which is cartographer speak for we know where we are. Only then do you measure the streak itself. A specialized model fits a trail profile, compensating for the way motion smears the light of a point into a thin ribbon. The fit yields a center line, length per exposure, and brightness integrated along the track. That last part is trickier than it sounds, because a streak spills into neighboring pixels like a chatty fountain. Mathematical fences keep the light counted once and only once, like a meticulous bouncer, checking stamps under ultraviolet. Next comes the time game. You correct timestamps to a common standard, so the measurements agree about when now happened, even if now was captured on a spinning planet arguing with itself about leap seconds. Subtle relativistic adjustments ensure that an object whizzing near the sun is not accused of time crimes it did not commit. Then the light curve is detrended for slow background changes and normalized so that a flat line really means steady behavior. Deviations can then be honest. A rise says a facet turned into sunlight. A fall hints at shadow or geometry or something more mischievous. Cross-checks are the reality tests. Independent telescopes contribute their own streaks and curves. each with different seeing, filters, and pet annoyances. When curves from different instruments hum the same tune, you trust the melody. When they clash, you go back to the headers, the lie detector readout, and hunt for the flare of a passing satellite, a thin cloud behaving like transparent gauze, or a subpixel guiding nudge that smears truth sideways. It is not glamorous, but it is the difference between wow and oops. The last mile is narrative. Analysts turned fit parameters into plain words. The object brightened by this much over this span, suggesting rotation. The trail angle shifted just so, confirming the glide through a known slice of sky. The integrated brightness implies a size within a cautious range. If we assume reflectivity, that is neither vanity mirror nor coal scuttle. Each statement walks with a shadow of uncertainty that is honest enough to ruin a headline and sturdy enough to build science. By night's end, the fire hose has turned into a ledger of clean measurements, and the ledger begins to whisper a rhythm that refuses to be flat. A pulse emerges, subtle, repeatable, a wink you cannot unsee. In the next chapter, we follow that wink and ask why the light blinked wrong and what kind of body spins a story into its own shine. Chapter 5, The Light That Blinked Wrong. The first graph that makes everyone lean in is not spectacular. It is a quiet line jittering across a screen, and every few minutes it lifts, then sags, as if the object is breathing under a thin blanket of starlight. That rhythm is the giveaway. Rocks do not breathe, but they do rotate. And a rotating body will show you different faces, some bright, some sullen. Early photometry, still smelling of fresh calibration, reveals a beat that refuses to settle into a tidy pattern. The curve does not hum a single note. It warbles. Picture a lighthouse with stage fright, blinking at the ocean, then forgetting its lines. What can make a visiting body blink wrong? Start with shape. If you spin a perfect sphere, the light strolls along with barely a wiggle. If you spin something stretched, flattened, or dramatically asymmetric, the glare rises and falls as angles change. Many small bodies are less like billiard balls and more like the result of a cosmic craft session, held with mittens on. Facets catch sunlight and toss it at us like small mirrors. Recesses hold shadow, the way pockets hold secrets. A long, skinny traveler, turning end over end, can show a brightness swing that feels like applause and then silence. The first guess is geometry. Our guest is oddly shaped and eager to show it. But the curve argues back. The timing between peaks is a little impatient in one stretch, then a little lazy in another, as if two rhythms are wrestling. That hints at tumbling, the unflattering term for rotation that is not lined up with any principal sense of order. Imagine a toy top that someone bumped at the wrong moment. It still spins, but the spin wobbles, processes, and occasionally improvises. In space, that mess can last a very long time, especially for a body that is not regularly reminded to behave. Tumbling turns a light curve into a duet, where neither singer agrees on the key. Then there is the possibility of venting, which sounds dramatic because it is. Certain ices, when warmed, sublimate into gas and dust, and that faint breath can change both the brightness and the push the object feels. Venting does not always announce itself with a dreamy tale. Sometimes it is a shy jet that whispers out of a crack and briefly paints a brighter patch before the geometry swings it away. If the jet is intermittent, the light curve will flirt with us, a pulse that is not quite in step with rotation, a rise that lingers longer than a simple surface feature would allow. It is the cosmic equivalent of a sigh you almost did not hear. Before anyone marries a hypothesis, the team tries to break it. Could the telescope or the atmosphere be playing percussion on our signal? Cross-checks with other instruments in other weather confirm the beat persists. The rhythm belongs to the object. Now the modeling begins in earnest. Think of it as a tiny theater. We imagine possible shapes, spin them under a virtual sun, paint them with patchy, realistic reflectivity, then watch what the simulated light would do from our vantage point. When the simulation starts to rhyme with the data, You feel the warm thrill of comprehension. When it does not, you adjust, stretch the body a bit more, move the bright patch, tweak the wobble, alter the tilt. Eventually, the model climbs close enough to the real curve to be useful, which is a fancy way of saying it is wrong in the right ways. One uncomfortable clue sits at the crest of each brightening. The top is not a sharp spike, but a swollen plateau, a lingering moment where the object seems to hold its face toward the sun, as if reluctant to turn away. That flavor of curve suggests a region with unusually good reflectivity, perhaps a fresh patch exposed by recent cracking, or a crust with frost laid down by a very gentle exhale of volatiles. Another hint hides on the downslopes. They are not mirror twins. One descent is steeper than the other, telling us one side of the body fades faster than its counterpart. Asymmetry upon asymmetry, which is the universe's way of telling us it is real. The team tests a slow leak idea. Suppose buried ices are insulated beneath a porous rind. As the visitor sweeps inward, heat sneaks through, pressure builds in tiny pockets, and a featherweight jet begins. Too modest to build a dramatic coma, but strong enough to brighten a small region and add a whisper of thrust. Now imagine that jet turning on and off as cracks open and close with the stress of spin and daylight. The light curve would inherit hiccups. Not chaos, just mischief. The data are not yet a confession, but they feel like a story clearing its throat. There is an emotional undertow to this work. Each new night extends the curve, and with it, the personality of the object sharpens, the precision gathers. The panic, quiet but real, comes from the clock. The visitor is moving fast, and every hour of good geometry is an hour we cannot borrow later. Meetings become brisk, jokes turn shorter. Someone starts calling the object a rotational overachiever, which is scientist for please slow down, we are taking notes. The mood oscillates with the curve, peak, cheer, dip, frown, anomaly, debate, repeat. Watching the curve in near real time feels like eavesdropping on a private routine. You learn that the brightest phase arrives slightly earlier each night, a clue that our viewing angle is changing as both we and the traveler sweep along our paths. That shift helps break degeneracies. With multiple nights and multiple look angles, the models lose some wiggle room. No single clean rotation period fits everything. A two-frequency solution whispers the word tumbling again, and the room nods, reluctantly impressed. Nature enjoys improvisation, and this visitor brought a jazz kit. A few minutes of humor keep the exhaustion friendly. Someone writes, "Rotate responsibly" on the whiteboard and draws a banana with a seatbelt. It is ridiculous and perfect. The curve on the screen is all grown-up seriousness, but it helps to remember the cosmos is not doing this to tease us. It is just being itself, with excellent timing and terrible consideration for our schedules. By the end of this stretch, we have something better than certainty. We have a short list of honest possibilities, each with testable consequences. If venting plays a role, then color should change during the brighter phases, as sunlight scatters off fine dust. If shape alone dominates, the curve will remain steady in color while brightness swings. If both conspire, the signatures will braid. To know, we need to listen, not just to brightness, but to the flavors of light, which means it is time to put a prism between us and the visitor and see what the spectrum whispers. Next, we raise an eyebrow at the rainbow and read between the lines. Chapter 6, Spectra, with a side eye. If light curves are the heartbeat, spectra are the accent. You slide a slit across a faint streak, feed it to a patient prism on steroids, and the white glimmer unspools into a rainbow with opinions. The first spectrum looks like a quiet hill country, broad slopes, small valleys, until you notice a few valleys are placed exactly where certain ices like to drink photons. That is the cinnamon in space moment. Familiar spice, unfamiliar kitchen, comforting, but also, wait, why here? Why now? Start with the basics. Sunlight bounces off the visitor. and carries a fingerprint of whatever it touched. Rocky stuff reflects in one way, dusty stuff in another, and volatiles, those easily persuaded ices that turn into gas with a little encouragement, leave telltale scoop-shaped dips in the rainbow. Observers stack multiple exposures to pull the whisper above the noise, line up the wavelength ruler so the colors mean something, then subtract the quiet glow of the night itself. What remains is the guest's profile, and it is not shy. The slope across the visible band leans redder than the sun, a common sign of weathered dust. That is expected for a traveler that has been sandblasted by cosmic grit and slow radiation baths between stars. But the near-infrared region carries the gossip. There, shallow troughs appear where water ice would snack on light if it were present as frost or mixed into grains. Another dip, faint but persistent, hints at carbon monoxide or carbon dioxide ices, the kind that usually cannot handle warm company. On an inbound path, those substances should be skittish. They either hide under a crust or they flee. Yet the spectrum says, in a lowered voice, they are here. Cue the side-eye from the spectroscopists. They are not easily impressed, and they are even less easily fooled. First question, could this be a trick of the instrument? The team rotates the slit to dodge nearby stars, takes spectra of standard lamps, and repeats the dance under different seeing. The dips stay. Second question, could dust alone fake the features? Certain grain sizes and mineral mixes can mimic gentle absorption, but not at those exact wavelengths, not with that shape. The cinnamon scent remains after you clean the counter. Next, the trace signatures. A tiny kink suggests organic molecules, a broad family that, in space terms, means carbon-rich structures wearing fragile bonds. No one leaps to life. The universe manufactures organics, the way forests manufacture leaf litter, constantly and everywhere, given enough time. But their presence, even as a rumor, says the traveler did not bake to sterility. Something preserved a pantry. Now the awkward part, temperature. As the object moves closer to the sun, its surface warms. You can estimate a ballpark temperature from its distance and reflectivity and arrive at a point where super fragile ices, like carbon monoxide, should be prone to vanish. If the spectrum still shows hints of them, perhaps they are not lounging on the surface. Perhaps they hide in cracks, shielded by dust, puffing through pinholes that repaint nearby grains with fresh frost. That would agree with a light curve that hinted at subtle mischief without a dramatic tale. Our visitor might be venting in a whisper and frosting its own face as it turns. Makeup by geology. There is also a flavor to the continuum, how the overall brightness changes with color that suggests differing grain sizes across the surface. Coarser grains scatter in one style, finer grains in another, and mixtures create blended slopes that are as diagnostic as shoe prints. The best fit points to patchwork. Some areas crusted and dull, others freshly dusted, maybe by tiny jets waking and napping as daylight walks across the body. The spectrum and the earlier rhythm in brightness are not twins, but they nod at each other in agreement, like two experts who refuse to say, "I told you so." One oddity refuses to sit quietly. The depth of the water ice hint is a little too shallow for a surface plastered with frost, yet too consistent to be dismissed. That suggests mixture rather than veneer, ice locked within grains of dust, a kind of cosmic granita. Such intimate blends sublime more slowly than pure slabs, allowing fragile compounds to survive closer to sunlight than expected. You end up with a body that sweats, not gushes, and leaves chemistry fingerprints without a showy tail. Low drama, high intrigue. Another subtle clue hides where silicate minerals announce themselves. On many small bodies, rock signatures peek through, telling you about ancient heating or violent pasts. Here, the silicate markers are subdued, as if dust and ice colluded to muffle them. That fits a traveler whose outer skin has been reworked by countless micro-impacts and the occasional thermal tantrum. The crust is not a window. It is a curtain, To keep everyone honest, the team grabs spectra at slightly different rotational phases. If a bright patch rotates into view, do the features deepen or fade? They do change, tracing a light choreography between brightness and composition. When the reflective region faces us, the organic hint softens, implying dustier areas hold more of the carbon-rich stuff, while frosted patches flash their water signature with a shy flourish. That phase dependence is gold. It transforms a single mixed message into a map with personality. Humor survives even here. Someone labels the feature plot spice rack and annotates dips with culinary jokes. It helps because the task is serious. We are trying to read a library card for a book printed under another sun, and the book might be overdue by several million years. The spice metaphor lands because the recipe is not native. These ingredients were assembled elsewhere and seasoned by interstellar travel. The fact we can taste any of it from so far away is its own minor miracle. Crucially, the spectrum also whispers about push. If airs are indeed escaping, even shyly, they can act like miniature thrusters. That would matter for the shape of the path. A tiny shove layered on gravity's pull. Spectra do not measure motion, but they hint at the engines. Pair that with precise tracking, and you can ask a delicate question. Is the trajectory curving only because of gravity, or is there a gentle breath nudging it off script? Which brings us to the next act. The numbers that pin the path are coming in sharper, and a small, consistent mismatch appears when you try to explain the motion with gravity alone. Gravity hates being ignored, and yet something seems to be tapping the visitor on the shoulder. Next, we listen for the nudge. Chapter 7, Gravity Hates Being Ignored. Here is the part where the orbit plot grows a conscience. For nights, we have been fitting the visitor's path with a clean, gravity-only story. The sun pulls, the object glides, planets add polite tugs, and everything lands within the narrow lanes of prediction. Then the residuals begin to mutter. They are small, but they are stubborn, and they lean in the same direction again and again, like a compass with opinions. The best fit improves only when you allow a tiny extra shove, a whisper of thrust not accounted for by any planet, moon, or known grumpiness of the telescope. Call it an invisible finger on the shoulder. Gravity does not like that, but the data vote yes. What could nudge a traveler that is otherwise committed to a graceful exit? The first suspect is outgassing, the slow release of gas from buried ices that have decided the season has changed. You do not need a theatrical tale for this. A few hairline cracks, a handful of sunlit vents, and the body can produce a sequence of microjets that act like control thrusters on a shy spacecraft. Each puff is almost nothing. Add them up over days, and the trajectory drifts just enough that the math notices before the eye does. The direction of the drift matters. If the push is mostly away from the sun, that smells like vents energized by daylight. If it lines up along the path, that hints at more complex geometry, as if the jets fire from spots that the spin brings on and offline, like reluctant engines. Second suspect, sunlight itself. Photons may be small, but they are relentless, and they carry momentum the way waves carry a shove. When light hits a surface, it can push on an object with a lot of area. Compared with its heft, that push becomes measurable. Think of a dandelion seed meeting a breeze. It is not much, but the seed does not weigh much either. This solar pressure does not care about vents or chemistry. It only cares about how big and how light the object is, and how reflective its skin might be. If our visitor is unusually fluffy or carries extended sheets, sunlight can act like a steady hand guiding a very patient sail. Between those two suspects lies a debate with sharp elbows. The outgassing camp points to our spectral hints of fragile ices and the light curve's personality. Those are consistent with a body that has pockets of volatile materials hidden beneath a crust, leaking politely. The solar pressure camp notes the underwhelming display in images. No dramatic coma, no clear plume, nothing that screams vent. If light alone explains the push, then perhaps the body has a surprisingly low density or an expanded shape that catches radiation efficiently, the spacefaring equivalent of a feather disguised as a stone. There is a third, quieter voice at the table, heat re-radiation. When sunlight warms one side of the body, and that side spins into night, the stored heat escapes as infrared light with a slight delay. That delayed glow can impart a tiny thrust. Over years, that effect can move small asteroids noticeably. Over weeks, for a sprinting interstellar visitor, it is a footnote. Still, the grown-ups keep it on the list because physics likes to stack small things until you call them big. Before the argument leaves the building, the team audits the boring possibilities. Did we point every frame at exactly the right stars? Are the timestamps harmonized to the same drumbeat? Did a planet's gravity get miscounted by a rounding error hiding in a script? None of those checks rescue the gravity-only fit. The nudge survives, resilient and annoyingly confident. At this point, the conversation moves from "is there a shove?" to "what kind of shove? How strong? And where does it point?" To answer that, modelers add a three-component force to the equations, one part pointing away from the sun, one along the flight path, and one sideways to the path. They do not write blackboard poetry. They simply let the computer adjust those tiny components until the path matches the measurements night after night. The winning recipe shows a modest outward push with a smaller along-track whisper. That balance makes sense if the visitor's daylight side hosts the action and the spin keeps shifting the vents by a few degrees between breaths. It also matches a gentler scenario for solar pressure, mostly away from the sun, with a tasteful side of a long-track frosting. If the shape favors one direction during a spin, normal becomes the slipperiest word in the room. For a local comet, a non-gravitational drift is Tuesday. For an interstellar traveler with limited spectacle, the same drift feels exotic, but exotic only means unfamiliar comfort. The first interstellar guest taught us that outgassing can be sneaky. The second reminded us that activity can be messy in a language we do not fully speak. By the third, maybe normal is simply varies wildly. Bring options. The key is evidence that stacks, a light curve that suggests surface patchwork, spectra that whisper about buried frost, and an orbit that refuses to be explained by gravity alone. None is decisive on its own. Together, they trace a plausible outline. The solar pressure interpretation, meanwhile, invites its own portrait. If the object is very low mass for its size, perhaps a fragile conglomerate or a hollowed-out shard, sunlight could boss it around more than we expect. That picture poses questions about durability. How did such a delicate thing survive ejection from a foreign system and a long interstellar road trip without crumbling? It is not impossible. Space is gentle most of the time, and collisions are rare, but the notion raises eyebrows. As new ideas should. As one observer put it, you can be fluffy, but you still had to cross a galaxy's worth of lint traps. While the camps trade slides, a quiet truth holds. The numbers require a nudge. Whether that nudge is vents, light pressure, or a duet, the orbit has confessed. And that confession is not scandal. It is personality. We are not watching a hero ignore the sun. We are watching a traveler balance the sun's pull against its own small habits. The cosmos is not dramatic for our benefit, but it has a talent for making our models look slightly underdressed. The emotional weather follows suit. Relief, because an explanation built from familiar tools is within reach. Restlessness, because every interpretation invites 5 new questions. Humor squeezes in where it can. Someone writes on the board, "Gravity is clingy. Our guest is politely declining." It is the right mood. We will keep listening to the push as the path lengthens, but another storm is brewing outside the lab. The world has seen the plots, and the internet does not wait for peer review. Next, we visit the arena where 6 theories are born before breakfast, and only 2 survive until lunch. Chapter 8. The internet invents 6 theories before breakfast. The first plot leaks into the public feed, and the timeline does what it always does. It puts on a cape, 3 lab coats, and a tinfoil crown, then sprints into the morning with confidence usually reserved for weather apps in summer. Overnight, we collect a buffet of explanations plated with maximum certainty and minimum vegetables. Cosmic iceberg, obviously. Alien tech, naturally. Comet cosplay, pretending it is a rock so it can cut in line. Prank by physics, because the universe loves a practical joke. The thread count on those hot takes is high. The patience is not. Headlines arrive like sparklers. Mystery visitor breaks solar rules. Space object defies gravity. News sky thing might be everything. Comment sections hum. A grandmother posts a picture of her backyard meteorite. That is, lovingly, a barbecue briquette. A teenager uploads a simulation of a spinning rectangle that fits exactly 2 frames and declares victory. Someone with a planet emoji in their handle writes a 12-part series about the ethics of waking up comets. The vibe is a potluck where everyone brings chili and no one brings spoons. It would be easy to roll eyes and move on, but buried in the chaos is the reason science ever goes public. Curiosity leaks. People want a story that makes sense before lunch, and nature, bless it, insists on dinner. So we laugh gently at ourselves and start the slow work of turning improv into sheet music. That is where peer review steps in, not as a gate with grumpy guards, but as a pressure washer aimed at enthusiasm. First, the wild guesses get house rules. You want cosmic iceberg? Great. What temperature keeps it intact on the inbound path? And what thickness of crust prevents it from flaking into a glitter bomb? You want alien tech? Fine. Provide a power budget that explains the measured nudge without leaving a thermal glow brighter than a city at night. You want prank by physics? Lovely. Name the law we forgot, then show how it hides in the data without also breaking 3 space missions and a lunar eclipse. The moment a theory meets a ruler, it stops being a costume and starts being a candidate. Preprints bloom on the archive. They are the dress rehearsal before the critics arrive. Teams post careful pages with calm titles. Methods read like IKEA instructions that actually build a bookshelf. Plots carry shaded regions of uncertainty that look like polite storm clouds. While the public argues about aliens, the tables argue about calibration constants. Reviewers circle paragraphs with invisible red pens, asking the 2 questions that have saved more careers than coffee. How would we know, and what would change if we are wrong? On the sidelines, prediction markets and office sweepstakes flourish. Will it sport a tail in 2 weeks? Will the push fade after closest approach? Will someone claim it has a light sail? Jokes aside, these informal games do what games do best. They force players to pick numbers rather than slogans. A wager is a theory with a deadline. Meanwhile, journalists call the usual suspects. They want color, not color correction. The careful quotes are the hardest to write. There are several plausible explanations, each with testable consequences, says the scientist, which is accurate and about as satisfying to a headline as a salad to a dragon. Still, some reporters hang in there. They learn the difference between a hunch and a hypothesis, between a model and a miracle. They ask how many independent teams see the same nudge, how many instruments catch a similar blink, how many nights it takes to turn a rumor into a curve that stays put. Back on the forums, the theories refine themselves through sheer exposure to other people's eyes. The cosmic iceberg crowd adds math and loses volume. The alien tech crowd discovers that being mysterious is not the same as being motivated. The prank by physics morphs into a list of small forces and tiny delays that, when summed, look suspiciously like ordinary nature being annoyingly subtle. A miracle, once measured, becomes Monday. There is a quiet triumph in the way nonsense melts without anyone needing to shout. A good plot is kryptonite for a bad argument. You can watch a claim evaporate panel by panel as more data slides in. That does not mean the internet goes silent. It is never silent. It means the center of gravity shifts from opinion to prediction. When someone says, if this is venting, then color should drift during bright phases, That is not a belief, that is a test. When another replies, if this is solar pressure, then the push will align mostly away from the sun and stay steady. That is not a vibe. That is a measurement waiting to happen. Peer review, the official version, moves slower than a thread, but faster than a glacier. Referees are unpaid, unseen, and powered by equal parts duty and stubbornness. They ask for additional figures, for simulations with different starting guesses, for the boring checks that keep exciting claims from becoming embarrassing retractions. Authors revise with the resigned joy of people who know the paper will be better when the bruises fade. The best exchanges feel like two climbers tossing a rope back and forth until both are clipped in. And the audience, it does what audiences do. Most drift on to the next, flashing thing. Some stay and discover that the patient middle of science is where the real drama lives. Ideas trimmed to fit the shape of the evidence, not the outline of a fantasy. A few convert entirely and start arguing about phase angles and thermal lag in the comments, which is how you know the outreach worked. By late afternoon, the list of 6 theories has become 3, each with homework attached. Look for color changes, measure the push direction, search older images for a faint pre-discovery trail. None of these steps will trend. All of them will matter. That is the joke and the joy of doing this in public. The spectacle is the doorway, the discipline is the room, the frenzy fades, and the professionals return to their least glamorous, most powerful skill, doubt, with deadlines. They pull the raw frames again and stare at the pixels like accountants reading poetry, looking for the tiny cheats that noise and optics can perform when no one is watching. Next, we turn the lab into a crime scene, not with tape, but with code. We will dust the images for fingerprints and see what truth was smudged in the first pass. Chapter 9, Forensics on a Pixel Crime Scene. The images come back up like security footage. You only notice after the wallet goes missing. We freeze the frame, zoom, and begin the slow ritual that separates signal from shenanigans. Every pixel is a witness with a memory problem. Some tell the truth, some exaggerate. A few are chronic liars that blink when no one asks them to. Welcome to CSI Telescope, where the instruction to enhance is followed by 3 pages of methodology and a healthy fear of wishful thinking. First suspect, cosmic rays. High-energy interlopers that jab the detector and leave scratches that look suspiciously like comet graffiti. They arrive at rude angles, deposit charge in neat, needle-thin tracks, and occasionally explode into starbursts that impersonate fireworks. To catch them, we play time against them. Real objects move predictably between exposures. Cosmic rays do not repeat their performance. We stack pairs, subtract, and watch as the imposters vanish like soap bubbles when compared with their neighbors. Algorithms trained on shape and context flag single-frame spikes with the enthusiasm of a hyperactive librarian. That is not in the catalog. Please remove it. Next up, hot pixels. These are the veterans of the sensor who have decided they are done with subtlety. They glow even when darkness should be the dress code, and they glow in the same spot night after night. Helpful in a way because a repeat offender is easy to blacklist. We build a mask, a tiny dotted constellation of do not believe points, and fold it into every reduction. If a streak crosses one, we do not panic. We discount the contribution, the way a judge discounts testimony from a witness who keeps changing their hat. Then there is the quiet chaos of flat field illusion. The camera does not love every pixel equally. Some drink more, some sip less, and the optics shade the field so the corners feel like dusk. While the center sun bathes, we correct that with flats. Yes, but flats are snapshots of the instrument's mood at a particular moment. Dust moves, filters age, a speck shifts a millimeter and draws a ghostly donut that drifts between nights. The forensic trick is to avoid laundering the scene so aggressively that you bleach out the faint streak we care about. We test a ladder of flat corrections. Lighter, heavier Goldilocks, then choose the one that tames the background without unthreading the trail. Guiding errors are the slapstick of this drama. The mount hiccups, the wind taps the dome, and suddenly stars elongate in a single direction, like they all agreed to lean into a group photo. Our visitor's line rides atop that smear, and the question becomes, how much of the elongation is motion, and how much is mechanical shrug? We fit the star shapes first, building a model of the night's blur geometry, and apply that to the moving target so we can separate the telescope's signature from the traveler's handwriting. It is like peeling a watermark from a note to read the ink beneath. Background stars complicate everything with their stubborn habit of existing. A faint one, lurking where the streak will pass, adds brightness that does not belong to us. If we are clumsy, we will brag about a rotation peak that is really a stellar photobomb. So we run pre-streak frames forward in time, predicting which stars will underlie the track, and subtract their expected contribution. When uncertainty remains, we mark those epochs with a caution flag and refuse to make grand claims from contaminated minutes. Boring, yes. Necessary, absolutely. The optics have ghosts too. Bright stars just off frame can scatter light across the detector in arcs and flares that look like the sky remembered a postcard. These artifacts have distinctive geometry tied to the instrument, not to the heavens. We consult the ghost atlas. Yes, there is one. And check each frame against known patterns. If a flare overlaps our trail, we know the culprit and adjust weights accordingly. No melodrama, just triage. Saturation events are the loudest lies. A very bright star swells beyond its pixel boundaries, bleeds charge along columns, and paints vertical streaks that cut across everything like poorly parked semis. The correction is procedural. Identify the bloom, map its bleed, and quarantine the affected columns. Where the quarantine intersects our object, we accept a temporary hole in the record rather than pretend the data are fine. Silence is better than fiction. Noise itself is a character. Thermal noise murmurs more loudly on warm nights. Read, noise contributes a fine grain. Sky glow lifts the floor. We measure these separately, then propagate them into the uncertainty for every measurement. The romance fades, but the statistics improve. A point with small error bars means something. A point with large ones means maybe. Maybes are not villains, they are just shy. With the crime scene stabilized, we revisit the trail. We do not sharpen recklessly. Instead, we convolve with a point spread function, that night's fingerprint of how a steady light should look, and fit the moving streak with a forward model that accounts for motion during the exposure. That yields a center line, an integrated brightness, and a confidence interval that could survive cross-examination. We repeat this across frames and build a clean, consistent series. Now less haunted by the detector's whims, art meets caution when we consider stacking. Co-adding images along the predicted motion can boost the faintest signal, but it can also average in trouble if the prediction is off by a hair. We therefore stack in short runs with gentle shifts, validate that the trail sharpens rather than fuzzes, and stop before we start inventing clarity. Each stack gets a sister stack made from control regions with no expected trail. If the control stack magically reveals a streak, congratulations, you just discovered your own bias. Back to the lab. The tone in the room changes as the cleaned series emerges. The measurements tighten. The outliers confess their excuses. A few pet interpretations go quiet, replaced by a curve that breathes more coherently, and a path that drifts with honest subtlety. Even the jokes improve. Someone draws caution tape around a screenshot and writes, "Do not cross active photometry." Morale is a calibration too. By the end, we have not made the data prettier, we have made them truer. The difference matters. A single pixel repaired lazily can tilt a period estimate. An unmasked hot pixel can fake a micro flare. A cosmic ray allowed to masquerade as a wink could start a rumor that survives for months. Forensics is patience with tweezers, Now that the evidence table is tidy, the dynamicists can walk in without sighing. They have been waiting to feed this cleaned heartbeat to their shape models and spin solvers. The object's strange rotation will not admit simple answers. And that is fine. We have built a floor strong enough to dance on. Next, in Spin Doctors, we let the mathematicians lead and watch them coax a tumbling stranger into a plausible body. Chapter 10, Spin Doctors, Modeling a Tumbling Stranger. The mathematicians walk in like choreographers hired to teach a boulder ballet. They take the cleaned heartbeat of brightness and start sketching invisible limbs, asking what kind of body would throw light at us in this peculiar rhythm. The first assumption they throw out is the comforting one. This is not a steady top spinning around a single neat axis. The curve will not let them. The beats stack slightly out of step. The highs refuse to arrive at equal intervals, and the lows are cousins rather than twins. That is the signature of a non-principal axis rotation, which is a polite phrase for a tumble that never learned to sit up straight. The modeling begins with a guess, always with a guess. Imagine the visitor as a lumpy potato or a squash disc. Paint it with a map that is not a map yet, just regions with different levels of shininess to mimic roughness and frost. Now set it spinning in two ways at once. A fast whirl around a short axis and a slower wobble that makes the whole object precess like a sleepy top. Let a virtual sun shine. Place a virtual earth where we actually are. Watch the simulated brightness breathe. Compare the breath to the real one. Somewhere in that loop, reality complains, and the modelers adjust until the complaints turn into suggestions. They speak in the language of poles and periods instead of degrees and seconds. One period tells how quickly the object spins around a body axis. Another tells how quickly that axis wobbles around the overall direction of angular momentum, which is the cosmic way of saying the spin prefers one direction but cannot quite commit. The two periods braid together to produce beats in the light curve. When those beats line up, the curve grows loud. When they fall out, it quiets. The trick is to find values that keep matching the dance night after night as our viewing angle shifts and the visitor moves on. One early surprise is the shape that keeps winning. It is not a tidy cigar or a cute snowman. The numbers keep driving the solution towards something flatter, like a river stone that spent too long in a cosmic pocket. Flattened shapes elevate the difference between facing us broadside and turning edge on. They also play nicely with the odd plateau we saw at peak brightness, a hint that a wide, reflective region swings into view and lingers. When the best fits are gathered on a screen, they look like members of the same peculiar family, squashed, ridged, a little haunted. No one trusts a single model. They run ensembles, dozens or hundreds of slightly different bodies with slightly different spins, and see which families survive the gauntlet of data. They shuffle the photometry, withholding some nights, then rerun the fits to test whether the solution depends on a pet subset. They add a little noise to the synthetic light and check whether the recovered shape stays in the same postal district. Gradually, the field of possibilities narrows from a continent to a province. Not a portrait, but a silhouette you would recognize in a crowd. Then, the thermal team weighs in from the doorway with a cough. Whatever shape you adopt, they say, it must make thermal sense. A flattened body turns day into night, differently from a chunky one. Heat pools on the plains and escapes slower along the ridges. If the rotation is messy, some surfaces get irregular schedules of sunlight, which changes how frost survives, and by extension, how small vents would breathe. The shape modelers groan with good humor and slide another parameter into the sandbox: surface inertia, the measure of how stubborn the material is about storing and releasing warmth. The dance gets smarter. Peaks broaden, troughs sharpen, and a few particularly ugly misfits give up and go home. There is an odd comfort in how the tumble might have started. A body can be kicked into non-principal rotation by a glancing blow years or centuries ago, or by uneven venting that acted like tiny thrusters with bad timing. Once in a tumble, friction inside the object slowly tries to straighten things out, converting messy motion into heat. How slow is slow depends on the size, the rigidity, and the internal architecture. A loose pile of rubble damps differently from a single solid chunk. Our visitor's persistent wobble suggests a structure with enough integrity to keep the wobble alive for the whole dash through the inner system. That little inference about interior strength is a souvenir we did not expect when we started with a noisy light curve. As the models improve, the apparent bright patch in the data gains context. On a flattened body, a single high albedo region can dominate the light curve for a disproportionate span of each cycle. The modelers test alternatives. Perhaps the bright patch is not paint, but a geometric effect, a smoother area that favors specular reflection at certain angles. Perhaps it is a frost deposit maintained by gentle venting. In run after run, the pattern that best follows the curve is a broad zone, not a speckle, that pushes the portrait away from a pockmarked rock toward a traveler with regional character, like a world with one cheek more polished than the other. One almost storybook moment arrives when two very different starting shapes converge to the same observational behavior. A squat diamond and a flattened oval, given the right blend of tumble and bright region, can impersonate each other in brightness. This is the famous villain in every inversion problem. Multiple shapes can masquerade as the same light curve. The way out is to change the lighting. As the geometry of Earth and Sun shifts over nights and weeks, the imposters fail at different phases. Extra data unties what math alone could not. The team circles dates on a calendar where the distinction will sharpen and begs the weather to be kind. When the provisional winner is chosen, the mood in the room is part satisfaction, part mischief. The model is not the rock. It is a puppet that behaves like the rock when the lights are set just so. But it carries consequences you can test. It predicts how the brightness will waver tomorrow and where the stubborn shove against gravity should point if vents hide near the bright zone. It forecasts a subtle color change when the reflective patch rotates away. In other words, it dares the sky to disagree. The humor never leaves. Someone names the leading shape the cosmic stingray, another votes for griddlestone, and a third carves a foam model with a box cutter, because holding a thing, even a wrong thing, helps the brain. The foam glides under a desk lamp, while the room hums with the soft percussion of keys. It is interpretive dance, yes, but scored to data. We end this chapter with a shape that seems to fit and a tumble that refuses to be ignored. The choreography tells us where and when sunlight lingers, and that points to where gentle vents would show their hand if they exist. So the next act is quieter, almost rude in its subtlety. A breath you cannot see, a push without a tail. We will ask how to catch a leak in a vacuum with nothing but light and patience. Chapter 11. A breath you cannot see. Outgassing without the obvious picture. A traveler that never raises its voice. No pearly veil, no billboard tail, no photogenic halo to delight a magazine cover. And yet, every night, the path bends a hair more than gravity alone would dare. Something is exhaling, but doing it with the manners of a librarian. The question becomes, how do you catch a whisper in a vacuum? Start with the skin. Small, icy bodies that spend time in sunlight develop rinds, dusty crusts welded together by heat and cold, repeating like seasons on fast forward. Beneath those crusts, volatile ices hoard their cool like mizzes. When daylight creeps in, warmth burrows only so far before it fades, a shallow tide of temperature that never reaches the deep pantry. That boundary is where mischief begins. Pockets of gas form as buried grains sublime, pressure rises, and the crust remembers it is not concrete. Hairline cracks open and close as the surface flexes under spin and day, like a cosmic creme brulee tapping itself with a spoon. Each tap vents a breath, not a roar, a sigh. A classic comet coma requires generous gas flow that drags dust into space, creating a fog bright enough to spot. Our visitor is stingier. Think of slow leak jets seeping through pinholes, not enough to sweep a plume, just enough to repaint nearby grains with frost and impart a nudge. The thrust from each vent is tiny, but tiny multiplied by relentless can move the needle. That is why the observed push does not throw fireworks. It behaves like a gentle hand that never tires. Those vents will not sit neatly at the hotspot and stay there. On a tumbling body, sunlight prowls around in strange patterns, switching on different neighborhoods at odd hours. A spot that slept through morning might wake at a slant in the afternoon. Another patch may catch a quick blaze and then plunge into shadow. The upshot is a choir of offbeat whistles rather than a single jet engine. Their sum, averaged over many spins, can still point roughly away from the sun, which is what the trajectory prefers, but with a little along-track frosting when geometry lines up just so. What about chemistry? Water ice is the reliable workhorse, but there are other players with lower boiling nerves. Carbon monoxide and carbon dioxide want to flee early, yet even they can loiter if the grains are mixed with dust. When ice glues itself to mineral particles, it sublimates more reluctantly, like a stubborn popsicle clinging to its stick. That mixed texture slows the escape and smears activity over a broader temperature range. The crust does not need to shatter. It only needs to breathe through pores and pinholes. This is stealth venting. No dramatic plume, just microjets whispering through a sieve. There is a perversely elegant cycle at work. A jet starts, carries fine frost a short hop, and redeposits it downwind on the surface. That fresh coat brightens a patch, which matches the elongated peaks we saw in the brightness rhythm. Then the patch warms, the new frost leaves again, and the reflectivity slides back toward dull. From a distance, we see an object that blushes and pales on cue, not because it loves attention, but because it is constantly repainting its own face with breath and light. Thermal stress plays percussion. Each swing between day and night makes the outer millimeters expand and contract. Over many cycles, those tiny strains convince the crust to fatigue. Grains grind against each other, seams unzip, and microfractures connect like alleyways in an old city. Now the path for gas is not a straight pipe, but a maze. Flow through a maze is fickle. It starts late, ends early, and occasionally decides to take a holiday. That fickleness turns a simple jet into a flicker. The thrust you measure is the average of 1,000 tiny decisions the crust made while you were looking away. We can test parts of this story without ever touching the visitor. If slow leaks rule, color should shift subtly during the brightest phases as sunlight scatters off transient frost and fine dust. Infrared observations should catch a whisper of warm spots lagging behind the daylit regions, the telltale sign of heat stored in shallow layers and bleeding out after sunset. If the vents are really pinpricks, polarization of reflected light may change with rotation because frost and dust polarize in different ways. None of these signatures is fireworks. All are receipts. The shape we inferred earlier makes the venting puzzle even juicier. A flattened body offers long, mostly level expanses where gas can flow sideways under a crust before finding daylight. That lateral plumbing means a vent does not have to sit exactly where the sun is brightest. Gas can commute. Now, the direction of the thrust depends on the route through that subsurface maze, not strictly on the lamp in the sky. It is messy and delightful, and absolutely the kind of complication nature adores. Could sunlight alone push the body without any breath at all? Possibly, if the traveler were unusually light for its size. But then we would expect a push that is very steady and almost perfectly away from the sun. Our data show a nudge that agrees with outward pressure, while retaining a faint along-track spice that rises and falls with the brightness rhythm. That pattern is the calling card of activity tied to rotation, vents that take turns rather than a sail that never blinks. The truth may be a duet. radiation pressure, humming a bass line while microjets improvise the melody. There is a final, almost cheeky consequence of slow leak venting. Torque. Each tiny jet applies a twist. Over time, those twists can adjust the wobble, either damping it or, if ill-timed, keeping it lively. A visitor can therefore maintain its messy spin precisely because it leaks politely instead of exploding. The universe loves feedback loops. This one is a metronome made of frost and sunlight. Standing back, the portrait that emerges is anticlimactic in the most satisfying way. No alien gadgetry, no impossible materials. Just a small world with a sun-baked crust and a stash of shy volatiles, cracking and wheezing its way through our neighborhood, leaving force where it leaves no show. It is deliciously unstable, the kind of instability that writes its signature in millimeters per second and dares you to measure. If this is how the traveler behaves, then its past matters even more. What nursery made an object with these ingredients and this attitude? Which stellar towns bake such crusts, blend such grains, and then toss their leftovers into the dark? In the next chapter, we will trace the path backward beyond our sun's jurisdiction and try to pin a birthplace on a map that refuses borders. Chapter 12. Birthplaces on a map with no borders. Rewinding the path of a runaway is equal parts astronomy and humility. Past the last whisper of planetary tugs, you let the sun fade into a background actor and hand the traveler to the Milky Way itself. The coordinate system changes tone. We are no longer tracing an ellipse in a tidy solar diagram. We are threading a needle through a loom that is moving, where the threads are stars with their own errands. The question is not just where was it, but where was everything else when it passed? Because space has no street signs, and the neighborhood does not hold still. The first move is to clone the path 1,000 times. Not evil twins, statistical siblings, each nudged within the measurement uncertainties. You fly them backward through a model of the galaxy's gravitational field, a calm ocean built from dark matter, starry disk, and bulge. The clones spread like a deck of cards, fanned across a table if they converge near a particular star's past position, and velocity, you get a goosebump hint. Maybe the traveler once shared a sky with that sun. If they refuse to agree, you accept the quieter answer. The origin is not a point, it is a region, a story written in probabilities. Stellar neighborhoods complicate and enlighten in equal measure. Young associations drift like schools of fish, coherent, moving, full of planets, either forming or remembering how. A passing through such a group raises the odds that some star's early chaos tossed a fragment into the void. Older moving groups are calmer, which is why they are less likely to throw rocks today, though their pasts might be messier than their current ID photos. Our backward threads check for both. Did the visitor's clones brush by a nursery with a reputation for overachieving in planet production, or a quiet elder that once lived in a crowded cluster where gravity played dodgeball? There are at least 3 plausible factories for a body with shy volatiles and a taste for independence. The first is a planet-forming disk that made more worlds than it could manage. Giant planets migrate. They do not tiptoe. As they march inward or outward, they scatter smaller bodies like confetti at a parade the city did not permit. Some fragments find stable havens. Some become moons. Some take one chaotic slingshot too many and achieve escape speed. If our visitor was born in such a disk, its chemistry would carry a freezer's memory. Ices blended with dust, layered by seasons in a cold zone before eviction. The traveler left home early, which would explain why its crust is seasoned but not anciently desiccated. The second factory is a graveyard with active landscaping. The exocomet cloud. Around many stars, a distant shell of leftovers waits, only marginally bound, like marbles on a stretched rubber sheet. The galactic tide, our galaxy's slow, large-scale gravity, tugs on that shell. So do passing stars and the occasional molecular cloud with the personality of a bulldozer. Every so often, A body is nudged inward to become a comet, or outward to become a citizen of nowhere. If that is our guest's story, then its long interstellar road trip could have started as an absent-minded stumble over the edge of a star's domain. The volatile hints we read earlier would fit a life spent in deep cold until the day the border moved without warning. The third factory is a chaos you would not want to mortgage in, a compact binary or crowded birth cluster, where gravitational banter crosses into demolition derby. Two stars trade angular momentum like gossip, a giant planet wanders too near, or a newborn stellar sibling alters the architecture with a close pass. In those neighborhoods, it is common for small bodies to be launched on outbound trajectories, with no return option stamped on the ticket. If a system like that was young when it ejected our traveler, the object could have formed with fresher ices, and only later acquired the crust and quirks we see now, marinated in starlight and micro-impacts during the long drift between suns. How do we weigh these scenarios without a forwarding address? We let dynamics and chemistry talk to each other. The backward clones whisper about kinematics, what relative speeds the traveler likely had near potential parent stars, and whether those speeds match what an ejection mechanism can provide. The spectral breadcrumbs hint at temperature history. A body that spent eons basking near a warm star would have shed its most delicate ices. Our visitor still smells faintly of them. That tilts the scale toward a cold upbringing and either a gentle ejection from the outskirts or a youthful toss before the oven really preheated. There is also the question of time. Interstellar space is kind to endurance. Collisions are rare. Erosion is slow. An object cast out billions of years ago could arrive with its core recipe intact, but its surface rewritten in haiku, thin lines of radiation damage, broad strokes of micrometeorite polish. If the traveler's wobble has not damped much, as our spin sleuthing suggests, that hints at a structure that can keep a messy rotation alive for ages. That resilience plays well with a long exile. It suggests a compact interior, a dignity under pressure, the kind of build that shrugs at a few million lonely years. We should admit a detective's bias. When the clones do not converge on a single star, we still love a good narrative. A likely region emerges, a patch of the local arm, where several star-forming episodes have flowed past one another like overlapping eddies. In that turbulent history, young systems shed more debris than they kept. Some of it, by luck and inertia, became our guest. The map on the wall, if we drew it, would not have borders. It would have arrows, dates, and a cheerful note that says Origin Confidence, watercolor. Humor keeps the work human. Someone labels a candidate region, the comet cul-de-sac, on a draft figure, and writes, in smaller type, residents prone to throwing yard sale items across interstellar property lines. The joke lands because the numbers underneath are sober. We are migrating away from the romance of a smoking gun toward the sturdier truth of likelihoods under motion. In the end, birthplace is not a pin, but a lesson. Planetary systems export what they cannot keep. Clusters make and break architectures. The galaxy is a slow machine that nibbles at the edges. Our visitor is a postcard from those processes, stamped not with a return address, but with a cancel mark that reads, ejected, no forwarding. Next, we lay our postcard beside two others we have received and ask what the trio, odd as they are, tells us about the kind of traffic the galaxy sends our way, and how often to expect the next knock on the door. Chapter 13, The Mirror Test, comparing 1I, 2I, and 3I. Lay the three guests on the table like forensic artifacts, and the table starts telling jokes. The first carries a minimalist vibe, small, hard to pin down, brightness doing yoga, path nudged by something that was not just gravity. The second arrives with the opposite energy, classic comet couture, a streaming veil, chemistry you could spot from the cheap seats. The third, our current headliner, splits the difference with a restrained exhale and a swaggering path. If you were hoping for a tidy family resemblance, sorry, Interstellar visitors have read the memo about brand differentiation. Start with speed, the resume item that gets attention on entry. All three showed up with the right kind of nerve, fast enough that even if the sun begged, they were never staying for brunch. Their approach speeds differ by a handful of kilometers per second, which sounds like paperwork until you realize those handfuls change how long we get to look, how bright they get, and how violently sunlight knocks on the door. The skittish one zipped by like a rumor. The gregarious one lingered just long enough to pose. The new one splits the tempo, giving us a middle act that feels generous in observation time and ruthless in mathematics. Color next, the paint swatch that rarely lies. One leaned reddish, the sort of tone you get from a surface that has sat through ages of gentle radiation and dust varnish. Another looked closer to the palette of familiar long-period comets, a mix that says, yes, I have been in the freezer, thanks for asking. The third complicates the art critic's job, a slope that softens toward neutral, in places where frost briefly repaints the canvas, then warms again when the coat fades. Side by side, the trio tells you that interstellar weathering is not one recipe. It is a cookbook with regional dialects and messy margins. Spin is the personality test, and the answers do not match. One of the pioneers gave us a light curve that oscillated like a tall story. Big swings, non-repeating quirks, the unmistakable signature of a shape and rotation state that refused to be the teacher's pet. Another twirled in a manner more polite, the sort of rotation that comets rehearse when they want to look respectable. Our current guest, a double time routine, a wobble woven into a whirl, with peaks that linger and troughs that disagree. Viewed together, these rotations say less about identity and more about survival. Ejection from a distant system does not ask whether you will spin gracefully. It throws you out and lets time decide whether you become a top, a wobble, or a dancer on a sticky floor. Now for the tender subject, the extra shove. One early visitor carried a small but undeniable non-gravitational nudge that ignited debates that boiled down to how invisible can a jet be, and still right in the margins of an orbit. Batuta the second arrived with the decency of a coma that made the shove feel like normal cometary business. The third's push is subtler than the second and bolder than the first, measurable, mostly outward from the sun, with a trace of a long track spice that suggests rotation-timed exhalations. In the mirror, the pattern that emerges is not scandal, but modesty. Interstellar bodies can breathe without coughing. Some show you the perfume bottle, some leave only the scent. Size is an exercise in guesswork, but comparison helps. The first likely skewed compact, small cross-section, big personality. The second wore a larger silhouette, a crowd-pleasing nucleus draped in gas and dust. The third lives in the middle lane, its brightness consistent with a body that is neither pebble nor mini-world, wrapped in a rind that edits how sunlight scatters. If you are planning a mission, these differences change the script. One asks for a nimble chaser, one rewards a long stare, and one dares you to bring both patience and sprinting shoes. Composition, the secret sauce, comes across in hints rather than declarations. The Comet Forward guest broadcast familiar volatiles. The enigmatic one kept whispering about ices without putting on a parade. Our current visitor adds a new accent, signs of mixed grains and frost that turn on and off, plus organic whispers that ebb with rotation. Put those three spectra on a wall and they read like postcards from different kitchens. Similar staples, different ovens, different seasoning, same underlying ingredient list. Small worlds are messy. So, where are the patterns you can use to sleep better? Here are the ones the mirror grudgingly grants. First, the galaxy exports all styles. There is no single template for an interstellar object, only a shared citizenship in the club of things that refuse to be trapped by one star. Second, time of arrival bias is real. We notice what it is possible to notice, and fast loners beating a clean drum will always look weirder at first glance than loud comets with neon signs. Third, measurable pushes show up even when displays do not. That means gentle activity and low-density skins are not rare. They are likely habits, not exceptions. Just as important are the non-patterns, the negative space you do not get to fill. Shape diversity is broad enough to make sculptors blush. Spin states resist one-size-fits-all narratives. Compositional hints overlap but do not align into a tidy lineage. When you meet three guests and none brings the same dish, you stop writing menus and start setting extra plates. The potluck metaphor is cute because it is true. Each visitor arrives with context. You cannot guess from the last one. The operational lesson lands with a thud. Detection pipelines cannot prefer one flavor over another. Follow-up has to be bilingual, capable of chasing shy objects that demand sensitive photometry, and capable of mining loud comets that deserve high-resolution spectroscopy. Theory must be equally amphibious, ready to explain gentle venting on small, reluctant bodies and robust outflows on diva comets. And the public script must evolve too. If the first guest made headlines for mystery and the second for spectacle, the third story is precision. The poetry of small forces measured well. Humor, because we need it. If interstellar objects are a potluck, our job is not to guess the casserole in advance. It is to label the allergens quickly. Speed, spin, shove, and spectrum are the four food groups. Feed those into the community kitchen, and you get something nourishing. A statistical sense of what kinds of debris other systems shed, and how often that debris wanders through our yard. The mirror does not flatter. It tells us we are still early in this genre. 3 samples is not a trend. It is a teaser. But the teaser is loud enough to reorder the to-do list. If variety is the rule, preparedness has to be elastic, which is exactly where we go next. From the romance of comparison to the spreadsheet of consequence, planetary defense is sharpening its pencils, revising its cadence, and asking hard questions about how to greet the fourth visitor without improvising the whole play. Chapter 14, Planetary Defense rewrites its to-do list. One zippy alien rock later, the playbook looks like it went through a washing machine. The old comfort script, detect, confirm, publish, observe at leisure, gets annotated with urgent handwriting, widen the net, shorten the handoff, and prepare hardware that can sprint. Planetary defense is not only about the big cinematic threats, it is also about dignity against surprise. The fourth visitor is somewhere out there auditioning. We would like to know our lines before opening night. First, sensor coverage. The sky is huge and rude. A handful of wide-field sentries can miss a fast, dim speck that slides through a gap or arrives from a sunward direction where ground telescopes squint. The new to-do list pushes for redundancy that overlaps like scales. Northern and southern hemispheres, yes, but also dusk and dawn watchers to catch sunward approaches, plus infrared eyes that are allergic to glare, less than humans are. Low Earth orbit patrols can see around weather. High orbits get longer, deeper stares. The dream is orchestration, a cadence where different instruments trade verses so quickly that an object cannot duck between notes. Second, follow-up telescopes. The rule now is immediate choreography. When a candidate pings the wire, the baton cannot wander. You want a global ring of medium and large mirrors on a prearranged sprint plan. Light curve specialists, color catchers, spectroscopy sharks, and radar, if geometry allows. It is a relay race with one runner already winded. Automation helps. Telescopes that can leave a sleepy galaxy survey and swivel on command. Pipelines that push preliminary numbers to the right desks before coffee cools, and prioritized queues that do not negotiate when a new guest knocks. The culture shift is subtle and profound. Less we will get to it tonight, and more plug in now. Third, the classroom. You run drills, real ones. You announce a mock interstellar target to a closed list, and the world practices the response. Who calls whom? Which instrument goes first? What exposure times? What message to the public that is accurate and calm? Afterward, you grade yourselves. Where did time leak? Where did software sulk? Which telescope forgot it still had a safety limit from last year's maintenance? The goal is to make competence so boring it becomes muscle memory. Drama is for the visitor, not for us. Now the part with rockets. Rapid response rendezvous sounds like a contradiction. Rockets dislike hurry. They are calendars attached to fire. But they can learn. There are two paths. Keep a small spacecraft sitting fueled and bored, or keep a kit of parts that can be assembled and launched in a hurry when a target appears. The first costs money in patience. The second costs time in chaos. The new to-do list sketches hybrid plans. A small bus with generic brains and eyes can wait on a shelf, while mission-specific bits, filters, dust counters, a tiny mass spectrometer, a deployable camera for formation flying, sit packed and certified. The call goes out, the kit becomes a probe, the probe meets a rocket already booked for short-notice rideshare or a dedicated small launcher on government retainer. Will it be elegant? No. Will it be fast? Faster than our pride. Propulsion choices bow to the calendar. Chemical engines sprint well, but run out of breath. Solar electric thrusters loaf at first and then outrun your expectations if you start early. The compromise for a pop-up visitor is often a chemical kick to leave Earth's side, followed by gentle electric push to trim the path. You are not orbiting the object for tea. You are aiming for a disciplined flyby with the camera pointed and the instruments awake. If fortune smiles and the geometry allows a slower overtake, you add a CubeSat companion that detaches for a second viewpoint. Formation flying turns one pass into a mini stereo lab. Autonomy becomes the unglamorous hero. A fast flyby gives you seconds to minutes of prime data. You cannot steer from Earth with the finesse of a gamer when signals take minutes to arrive. The spacecraft needs to recognize the target, center it, adjust exposure, and ride out a brightness swing without panic. That means rehearsals with simulated targets and a guidance system that has seen every trick the universe is likely to pull, plus a few it will invent for spite. The motto is simple: do not send a tourist, send a driver. Communications and data triage are part of the sprint. You preload compression tricks and priority lists so the probe knows which bits to beam home if the downlink throws a tantrum. Highest priority: the close approach images, spectra through the key windows, and any dust impact readings that tell you whether the visitor is shedding. Lower priority: everything else. Later, the stored archive trickles down for the patient among us. Spacecraft are like good reporters. File the headline first, then the features. But what if we cannot fly? Most nights we will not. Budgets are real, windows are cruel, and rockets have their own opinions about weather. The to-do list does not gamble everything on a spacecraft miracle. It also doubles down on smart ground and orbital assets, high-speed polarimetry to catch surface texture changes, thermal instruments that can be scheduled out of turn, and a network of small telescopes with identical cameras so data can be pooled without arguments about calibration. Think of it as swarming with photons rather than aluminum. Policy and paperwork sneak onto the list as well. You write pre-clearances for range time, legal templates for rapid international data sharing, and memoranda that say, in plain language, who flips which switches when stress makes polite emails feel like novellas. The public script gets pre-written skeletons. What to say if the push is large, if it is small, if the visitor is bright, if it is moody, clear beats clever, calm beats viral. Finally, there is a philosophical item that looks suspiciously like a heart: curiosity as infrastructure. If interstellar potlucks keep serving different dishes, the best defense is not a bunker. It is a kitchen that can cook anything. That means funding software that can pivot, instruments that can swap modes, and people who can go from sleepy survey to emergency ballet without breaking. It means accepting that surprise is not failure. It is the product. Rockets may not love hurry, but they understand rehearsal. Give them flight-proven buses, standard ports, and a standing date with a launch pad. And even a fussy booster can play sprinter when the starter pistol fires. If we do this right, the next guest will meet a planet that looks less startled and more prepared to listen up close. Up next, the debate round. With data in hand and a to-do list sharpened, the crowd-favorite bout begins. Ice versus dust versus sunlight. 3 models enter. 1 wobbly consensus leaves. Bring helmets. Chapter 15, the ice versus dust versus sunlight debate. Cage match 3 hypotheses. Walk into a colloquium and set their laptops down like dueling pistols. In the ice corner, slow leak vents from buried volatiles whispering thrust. In the dust corner, a body so light and airy that sunlight can shove it around like a feather. In the sunlight corner, not just pressure, but heat absorbed and re-radiated at a lag, turning warmth into a tiny engine. The referee is evidence, the clock is geometry, and the crowd is caffeinated. If your favorite model survives this round, buy it a helmet. First, the ice case steps forward with a folder of receipts. The light curve shows a rhythm that refuses to stay perfectly even, as if some surface feature sometimes brightens more than it should, and sometimes not at all. Spectra, meanwhile, carry hints of frost flavors that prefer shade, plus a faint suggestion of organics that like to hide in dustier patches. Put those together and you get a surface that occasionally repaints itself with thin frost and then forgets to reapply. That behavior would produce thrust that is strongest when certain longitudes face daylight and weakest when those regions sink into shadow. The predicted signature, a push mostly away from the sun with a small along-track garnish, modulated on the rotation schedule. Our orbit fits lean that way. The ICE team smiles like detectives who found a partial fingerprint on the doorknob. The dust argument counters with elegance. You do not need plumbing if the furniture is light. If the body has very low density or carries extended porous layers, photon pressure alone can do mischief. Sunlight arrives, momentum transfers, and over days, a small, steady hand steers the path. No vents required, no chemistry excuses, no surprise parties. The prediction, a push that points almost exactly away from the sun, varies smoothly with distance and barely cares about rotation. It is a clean model that loves Occam as much as accountants love receipts. Sunlight's third act is subtler. Thermal lag, surfaces warm under daylight, then continue to exhale heat after sunset. That delayed sigh, emitted as infrared, carries momentum in the direction of last afternoon. On spinning asteroids in long romances with the sun, this effect can sculpt orbits over years. For a fast interstellar visitor, the window is short but not zero. The prediction, a thrust with a preferred direction tied to the spin and to how stubbornly the material holds heat. The catch, the magnitude is usually small unless the surface is tuned like a drum. The thermal lobby is calm, and calm in science is often a sign of experienced pessimism. Now evidence climbs into the ring. Color measurements during bright phases show slight changes that line up with the idea of transient frost and fine dust taking turns. That is a nudge for the ICE team. Polarization data, how the light is aligned when it bounces off the surface, favors textures that could be refreshed by very gentle venting, another whisper in the same direction. On the other hand, images do not show a showy halo, no obvious plume, no neon sign announcing outflow. Dust fans grin. Absence of spectacle is their favorite exhibit. The thermal camp asks a different question. Do the nightside regions appear warmer than they should? Early infrared hints say not by much, which puts a ceiling on how much delayed heat can help. We line up predictions against behavior. Ice plus rotation says the along-track component should wax and wane with a period close to the tumble. Dust only says the push should be steady enough to set a metronome by. Thermal says look for a phase shift between brightness peaks and the direction of the nudge. The cleaned astrometry, now free of detector gossip, shows a small but persistent along-track term that breathes with rotation, not a flat line. The dust-only model takes a standing 8 count. It is not out, but it is woozy. Here is where kindness kills pet theories. The ice advocates admit that if venting is the engine, it must be modest and patchy, the sort of trickle that refuses to build a grand tail. They propose tests that could hurt them, deeper color monitoring to catch frost cycles, high cadence infrared to chase hotspots, and a polarization campaign that watches the swing through a full wobble. The dust camp tightens its story. Perhaps it is not pure photon shoving, but photon shoving on a body with unusually large, fractal grains that increase effective area. They accept a test too. If that is true, the spectrum's overall slope should march in lockstep with phase angle, more tightly than it does. The thermal team, bless them, calculates upper bounds and concedes center stage, while insisting we keep their effect in the bookkeeping. No one leaves the room in a cape. Everyone leaves with homework. A quieter subplot threads through the bout. Torque. Whether gas squirts or sunlight taps, spins can change. If the rotation state drifts measurably over the observing archere, period lengthening or shortening by a hair, that is a stamp of activity rather than light alone. Preliminary fits hint at a tiny change, barely more than a rumor, but it tilts the crowd. Sunlight pressure alone does not twist you. Venting does. Then comes the mercy rule, parsimony with context. We already have spectral crumbs that smell like volatiles hiding in dust, a light curve that behaves like a surface with repeat offenders, and an orbit fit that prefers an outward push with a rotational accent. It would be perverse to throw all that out for the pleasure of a one-parameter model. The wobbly consensus forms like dew, a duet. Weak, patchy outgassing plays lead, sunlight pressure keeps the baseline, thermal re-radiation adds a quiet harmony. The exact mix depends on time of day on the object and our changing view. We keep the tone light because rigor is heavy. If your favorite model survives this round, buy it a helmet, someone writes on the whiteboard, and no one erases it. The helmet is for the next data release, the one that will test whether our tidy duet sings the same tune when the geometry shifts and the visitor slides outward, cooling its temper and its vents. And that, conveniently, is where the story heads. New reductions from other observatories are about to hit the inbox, promising sharper curves and cleaner spectra taken under different angles. The second dump could rescue a theory or retire it. Either way, we will be ready with helmets and erasers. Chapter 16. When the data blink back, hidden systematics. The night does not just shine, it negotiates. You think you are measuring a traveler's mood swings, and the instrument leans over and whispers, actually, you are measuring me. This is the sobering chapter, where calibration gremlins climb out from behind the monitor and demand union wages. Color terms flex. Transparency sulks. A perfectly innocent rise or dip in brightness turns out to be the weather practicing ventriloquism through your optics. Nature is hard, your camera is harder. Begin with the 0 point, the quiet boss of photometry. Every night, you agree on how bright is, by consulting standard stars that have behaved for decades. But the agreement is fragile. A thin veil of high cloud that no one can see, a barely noticeable haze near the horizon, a change in background glow, from air glow waking up after midnight. Each tilts the scale by just enough to nudge a light curve. You can correct for overall dimming, yes, but the night is not a uniform filter. Transparency breathes across the sky like a sleeping giant. One field stays honest while another catches a cold. If your object happens to be in the sneeze lane, your curve learns bad manners. Color terms are the diva move in this drama. Your filter says it admits a certain slice of rainbow, but the detector and the optics add their own opinions. The transformation from instrumental brightness to the real standardized value includes a color correction that depends on the object's spectrum. That is fine when your target behaves like the calibration stars. Our visitor does not. Its surface reddens and pales with rotation, frost blooms and fades. Fine dust comes and goes. Meanwhile, your reference stars are steady old souls with simple spectra. The mismatch means that as the night cools and the passband shifts a little, the instrument treats the object and the standards differently. The result can look like physics when it is, in fact, paperwork. Humidity is the shapeshifter, no one invited. It sneaks into the dome air, onto mirrors, into gaps. A trace of moisture on a lens does not announce itself dramatically. It softens the image just enough to alter how much light your chosen aperture captures. The seeing monitor may still report decent conditions, while the optics are wearing a microscopic sweater. Worse, water vapor in the atmosphere deepens specific absorption bands. If your filter straddles one of those bands, and your target's color is sliding, the measured brightness can wobble with humidity in a way that looks like rotation. On the plot, it is a wink. In the logbook, it is dew. Linearity is another quiet plot twist. Detectors promise that twice the photons mean twice the counts, but that promise frays at the edges, at very low levels where electronics mutter, and at high levels where pixels approach their comfort limit. If your target is faint and your sky is bright, the background lives in one neighborhood of the response curve and the object in another. Subtracting a background with slightly different behavior leaves a residue that masquerades as a real signal. You applaud the object for a small brightening that is actually your camera refusing to be a straight arrow at midnight. Point spread function drift deserves its own caution sign. As the telescope tracks, gravity flexes metal, temperature reshapes glass, and focus creeps. The star images fatten or sharpen across the field in patterns that are not symmetric and not constant. If you measure brightness with a fixed aperture, a star that grows a wider halo donates more light beyond your circle and looks dimmer for no cosmic reason. Aperture corrections exist to rescue you, but they rely on a handful of reference stars that might not sit near your target or share its mischief. A tiny mismatch compounds over hours into an invented heartbeat. On the astrometric side, the traps are just as devious. Differential chromatic refraction pulls blue and red targets by slightly different amounts as they climb and set. If your traveler's color changes with rotation and your plate solution assumes everything moves the same, the measured position can shift in step with brightness. Feed that into an orbit fit, and congratulations, you have created a phantom non-gravitational push that points wherever the atmosphere tells it to. The cure: color-aware astrometry and careful modeling of air's tiny prism steals time you wanted to spend doing glamorous science. Scattered light is a ghostwriter. The moon hangs well outside the frame. The field looks clean, and yet a low gradient of stray glow sweeps across the detector. Subtract a constant background, and the corners sulk. Fit a plane, and you risk subtracting a slice of your streak. Even the shape of the dome slit and the paint inside the tube matter. A bright star, 3 fields away, can sketch arcs of baffling that human eyes ignore and algorithms worship. If your target crosses the soft shoulder of one of those arcs, its measured brightness follows the furniture, not the physics. Then there is fringing at redder wavelengths, those delicate interference patterns that appear when night sky emission lines bounce inside thin detectors. They are faint, beautiful, and utterly unhelpful. A fringe pattern that shifts slightly with temperature can imprint a sinusoid into your photometry. If the period of that pattern accidentally rhymes with the rotation, you get a counterfeit chorus line dancing behind the real curve. Removing fringing requires building a library from many blank fields and trusting that tonight's pattern is a cousin of last night's and not a stranger. Catalogs, the bedrock of calibration, betray you in tiny ways. The bright stars used to fix the plate scale and orientation can carry color-dependent biases inherited from older surveys. A handful of mismeasured references in a corner pushes the solution subtly, and that push lands right where your streak lives. Combine that with a small drift of the mount between dithers, and you have a recipe for invented curvature at the level that matters for non-gravitational force detection. What do we do besides lose sleep? We build redundancy into the ritual, observe standard fields at beginning, middle, and end, not just once, track humidity and temperature like they are part of the sky, because they are. Allow the transformation from instrumental to real to include a term that can flex with color in time, not just color in general. Use multiple aperture sizes and insist they tell the same story. When they do not, listen harder. Fit astrometry with color in the model, even if it costs convenience. Generate synthetic stars with the measured point spread function and insert them into frames to test recovery. And when in doubt, throw away the prettiest points first. They are often the ones that learned how to be pretty from the instrument, not the universe. The joke lands lightly because it needs to. Nature is hard, your camera is harder. But there is comfort in the grind. Every gremlin tamed turns a suspicious wiggle into a credible whisper. And credible whispers are exactly what we need when the next wave of observations arrives from other eyes under other skies, which is where we go now. The second dump, the fresh reductions, the same object viewed from new angles, changing everything we thought we knew, and nothing at all. Chapter 17, the second dump changes everything, and nothing. Fresh files land like a second opinion from a doctor who actually read your chart. New observatories, new instruments, new nights under different skies, each with their own habits and allergies, drop their reductions into the pool. The first emotion is gratitude. The second is dread. Reinforcement can be a hug. It can also be a mirror. We line the curves up like fingerprints in a light lab. The anomalies we argued over last week now face a room full of copies. Some quirks shrink on contact. That suspicious midnight ripple? It dissolves when a site with steadier air and a differently colored passband watches the same cadence. A few proud spikes step down from physics to instrument with feelings. They do not vanish. They lose the right to speak loudly. Other anomalies, however, step forward. The slow, stubborn brightening that trailed the main peak in our original series, brushed off by some as a calibration side effect, reappears from a different hemisphere with the same timing, the same slope, and the same smirk. If an artifact can teleport, it deserves a Nobel. This one cannot. It is real. Spectra Titan II. Features that once floated at the edge of certainty stiffen their outlines when sampled with higher resolution and better sky subtraction. The waterish dip remains shallow but reliable. The carbon-friendly notch stops playing coy. Meanwhile, the continuum slope, that long tilt we read like weather, shows a tiny phase-dependent drift that we missed when all the light came through one instrument's personality. It is not dramatic. It is consistent. And consistency is drama for adults. Astrometry arrives with grown-up manners, color-aware solutions, careful refraction modeling, and a parade of reference stars that would make a catalogue blush all shave the scatter. The non-gravitational push we argued about slides inward by a hair less flamboyant than the early fit suggested, but still there, still pointing mostly away from the sun with a hint of a long track bias when the bright region faces us. The invisible finger has not disappeared. It has learned to use indoor voices. Then, the twist. A graduate student who refused to go home, academic subclass, nocturnal, overlays the multi-site light curves not by clock time, not by rotational phase, but by the visitor's solar latitude, the angle between the sun and the object's spin-defined equator, as inferred from our best tumbling model. The room goes quiet in that way people do when the coin they were flipping lands on its edge. The peaks migrate with solar latitude like migrating birds. Not much, just enough to whisper, season. Season here is not a calendar with pumpkin spice. It is a geometric season. As the visitor sails through the inner system, its tilted, wobbling orientation changes. Which latitudes receive the most intense daylight? A high-latitude region that was grazing the light early in our campaign begins to bask longer as weeks roll by. In the stacked data, the bright plateau lengthens precisely during that interval. The post-peak shoulder fattens, the color drift slides in step, the pattern repeats across telescopes that did not share weather, optics, or snacks. It is a shy, elegant signal. The object has seasons. A seasonal effect explains why some nights felt unfair. When our line of sight favored the reflective zone, just as the sun climbed higher over its local horizon, we recorded overachieving peaks and argued about exotic chemistry. Weeks later, as geometry tilted the lamp toward a different swath, the same region cooled sooner, and the tail of the peak shortened. No new ingredients required, only changing sun angles on a lumpy world with a complicated spin. The relief in the room is audible. It is not relief if we got lucky. It is relief if we were not imagining things. Seasons also rescue the duet we adopted between slow leak outgassing and sunlight pressure. If frost is being redeposited near certain latitudes, then as those latitudes swing into longer daylight, vents there stay open a touch longer. Bright patches linger, and the along-track component of the push strengthens at the same times our brightness plateaus do. When the geometry reverses, both fade together. The push is not changing its personality, the stage lights are. With geometry on the stand, we revisit the why no dramatic coma question. The second dump's deeper stacks, co-added along the refined motion, reveal a whisper of excess light, extending a handful of pixels sunward at select epochs, just enough to hint at a low-contrast fan, just enough to be responsibly boring. The fan appears exactly when the seasonal model predicts peak insolation on the active latitude band. You can practically hear the object sigh. I am trying not to be obvious. Hidden systematics we fretted about in the previous chapter get their curtain call. Sites that struggled with humidity no longer drive the narrative because the new dry air curves carry the same seasonal drift. Color terms that made us cautious now help. Instruments with slightly different passbands sample frost and dust with different sensitivity, and both sets rise and fall in lockstep with solar latitude instead of local quirks. The joke stands. Your camera can be harder than nature, but today the cameras behaved and nature blinked on cue. Do we declare victory? Not yet. We sharpen predictions. The seasonal model says that as the visitor moves outward and the sun drops lower over the formerly favored latitudes, the plateau should contract, and the small along-track push should relax. The bright patch ought to lose some gloss as frosting cycles stall. Polarization should drift toward textures built by older grains rather than fresh frost. We schedule telescopes accordingly, because nothing is as satisfying as telling the sky what you expect, and having the sky disagree politely or nod with style. There is a philosophical turn here too. The second dump does not erase the first, it frames it. Early data gave us the outline. Late data draw the cross-hatching that shows depth. Everything changed in the sense that we can now tell a continuous story without stapling assumptions between chapters. Nothing changed in the sense that the traveler remains itself, a small, complicated body doing small, complicated things, with forces gentle enough to require respect and instruments honest enough to deserve it. Humor returns in a sigh. Someone writes seasonal affective delight on the whiteboard and underlines it twice. The delight is not that the mystery vanished. The delight is that the explanation is fragile and elegant and withstands being poked from 3 continents. Fragile explanations are the good ones. They force you to be careful and reward you for it. We tidy the plots, send courteous preprints back into the arena, and allow ourselves one glance ahead. The next chapter is not about curves or fits. It is about meaning. What did this visit teach us about the export habits of other solar systems? About our readiness to catch the next courier? and about the posture a planet should hold when the universe knocks. One more scene, then the credits. What the universe wanted to tell us, and what we plan to do with it. Chapter 18. What the universe wanted to tell us. The curtain falls on a tiny traveler and rises on a larger truth. Here is the message written in faint streaks and careful plots. Planetary systems are not tidy apartments. They are construction sites that never quite finish sweeping. They build worlds, they break a few, they box up leftovers, and, every so often, the moving truck hits a bump and a crate falls off. We call the crate an interstellar object and pretend the universe delivered it on purpose. It did not, but that does not make the postcard any less precious. The second message is about us. Our instruments used to be postcards too. Smudged, folded, arriving late. Now they are doorbell cameras that capture the visitor mid-sprint. That is not a small upgrade. It is a civilizational note that says our curiosity finally outran our clumsiness. We can watch a stranger skim past, hear its quiet breath, and infer the weather on a world lit the size of a city block from light measured across oceans. That is a magic trick performed with math and stubbornness. The applause is allowed. Humility walks in right behind the applause and taps the microphone. We did not coax a grand confession. We assembled a whisper. The object did not pause to pose. It gave us two looks and a shrug. We built a narrative anyway, but the honest kind, braced with uncertainties and lined with caveats. That is adulthood in science, resisting the urge to fill silence with certainty, letting the unknown sit at the table without making it the centerpiece. Wonder, but with guardrails. And wonder did its job. It reminded us that the galaxy is not wallpaper. It is traffic. We are not the cul-de-sac at the end of a quiet road. We are a house near an intersection. Other systems throw their crumbs into the dark, and once in a while, those crumbs rattle across our doorstep, glowing like the last ember from someone else's campfire. You can feel small about that, or you can feel lucky. I vote lucky. The universe is not staging a show for us, but it agreed to let us peek backstage. There is also a subtler lesson tucked in the light curve's shyness. Nature often expresses itself with loud phenomena, flares, tails, plumes, that even a sleepy instrument can catch. This visitor was not loud. It was careful. It taught us to pay attention to small forces, to let the numbers tell us something boring and beautiful. Gentle pushes matter. Seasonal tilts matter. Grains and frost write sentences in lowercase. We prefer uppercase. The universe prefers a whisper. We are learning to listen. What does this mean for the way we live under a wide sky? It means treating the night as a commons. The images were taken by many eyes. The curves were stitched by many hands. And the story got better every time someone else refused to believe their first plot. It means designing systems that assume the next interesting thing will not respect office hours. It means training students to debug as a philosophy, not a chore. It means telling the public the truth, that discovery is mostly patience wearing comfortable shoes. It also hints at a future hobby for our species, interstellar ethnography. Each visitor is a sample from a culture of planets we will not see directly for lifetimes. We piece together customs, how a distant disk freezes, how a young giant planet rearranges furniture, how a stray moonlet learns to survive in the long cold between suns. We will never visit most of those neighborhoods, but their trash tells tales. Humans have always learned by rummaging. The cosmos just gave us a larger bin. The emotional beat lands here, thankfulness, thankful that a small world risked nothing and taught us something anyway. Thankful that instruments built by committees and coffee performed like a choir. Thankful that a field famous for caution can still experience delight. There is humor in that, too. We obsessed for weeks over a brightness wiggle measured from an object smaller than a mountain. The Milky Way, unbothered, kept making stars. The mismatch is not embarrassing. It is the definition of perspective. So, what next? The tease is not a cliffhanger. It is a challenge. The fourth visitor is coming. Not this season, maybe not next, but soon enough that the whiteboard ink will still be fresh. Between now and then, we can choose to be ready in ways that move beyond hardware. We can agree on playbooks that travel faster than rumors, on data that leave their hometowns the moment they learn to walk, on pipelines that treat every candidate like a potential conversation with the galaxy. We can budget for the boring parts, because the boring parts are the engine. And yes, we can chase. In the next episode, we will lay out the mission ideas that stepped off the napkin and onto real timelines. Picture a small craft waiting like a sprinter in the blocks, a camera that can think for itself during a blink and you miss it pass, a dust counter ready to taste the breath of a foreign frost. Imagine a formation of tiny scouts peeling off to watch from two angles, giving us stereo on a story written in seconds. Rockets may not love hurry, but they can practice. We can too. If that sounds ambitious, it is. If it sounds like hubris, it is not. Hubris says the universe owes us a close-up. Humility says we should be grateful for a drive-by and prepared to earn a better view. The ending, then, is simple. A small rock from elsewhere taught a big planet to listen better. We will keep listening. And when the next knock comes, and it will, we will open the door with wonder in our eyes, caution in our hands, and a spacecraft warming up in the driveway.